Hello. So in this problem, we are given polar coordinates at a given point, and we have to convert them into rectangular coordinates or Cartesian points. So in our first part, we are given the points of 12 and 7 pi over 4. What we can first do is identify the r and theta values. So normally theta values are in radians or degrees form. So we gotta quickly identify that r is 12 and 7 pi over 4 is theta, and this is in radians form. Once we identify r and theta, we can use the conversion formula for polar coordinates to rectangular coordinates, being x equals 3 r cosine theta and y equals r sine theta. These two right here. Then we can plug in the values, which would be, for the x values, would be 12 cosine 7 pi over 4 and 12 sine, and this for the y values, 12 sine 7 pi over 4. If we look at the unit circle, we could find the exact radians or the degrees for both x and y, or cosine and sine. We plug in those values into the x and y values, and we get 12 times square root of 2 divided by 2 for x, and for y we get 12 times negative square root of 2 divided by 2. Once we solve for that, we get the final values for part 1, which are 6 times square root of 2 for x, and for y, negative 6 square root of 2. For part 2, let's switch over here, do the exact same thing. We identify the r and theta values. For r, we have negative 2, and for theta, we have 7 pi over 3. Once again, we use the formulas x equals r cosine theta, and for y, r sine theta. We plug in those values. For x, it would be negative 2 cosine 7 pi over 3, and for y, it would be negative 2 sine 7 pi over 3. The r value does keep its negative, but luckily we're not going the other direction with the angles. We look at the unit circle, and since 7 pi over 3 is a whole revolution, one revolution using the thirds would be 6 over 3. So we do one complete revolution all around the unit circle, and we end up having a third left over, meaning our angle would be pi over 3. Using these values for cosine and sine, we are able to plug those in into the x and y values, which would be negative 2 times 1/2 for x, and for y it would be negative 2 times square root of 3 over 2. Once we solve for that, we have the final values of negative 1 and negative square root of 3. And that is it. Simple as that.